Hello, everybody. Today we are going to start out with reviewing what we talked about last class with the quadratic formula. Jumping right into it, in order to use the quadratic formula, the first thing that I need to check is if my equation equals 0. Now, this equation right here does not equal 0. It equals -7. So what I have to do is I have to move that -7, get rid of that -7, make it 0. The way I get rid of that -7 is by adding 7 to both sides. So here, these cancel out. And what I am left with is 2m squared minus 3m plus 7 equals 0. So again, the order really matters. I need to have the squared term first, then the term that has the letter, has the variable, but isn't squared, and then at the very end, just the constant variable, the one without a letter. Now that we have this equation equal to 0, now I can identify A, which is 2, B, which is -3, and C, which is 7. And remember that when we do this, when we plug in A, B, and C into our quadratic formula, I am just replacing the letters with parentheses. So negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses, right? And inside of those parentheses, I am putting the numbers of the letters that those parentheses are replacing. So for example, in this first parentheses right here, the first parentheses right here, that used to be a B. So what am I going to put in there? B. I'm going to put -3. In this parentheses right here, that was a B, so I'm going to put B in there, which is -3. Then here, in this next parentheses, I'm going to put A, which is 2. And then I'm going to put C, which is 7. And then I'm going to put A on the bottom, which is 2. So now that I have this, I'm going to go to Desmos and plug this in exactly as I see it on my paper, if you're writing it down on paper. All right, so I am here in Desmos, and I am going to be typing exactly what we wrote down on our paper into Desmos to get my answer. So negative parentheses, -3. Remember that there is no plus or minus sign in Desmos, so I have to go one at a time. Plus, square root button over here, square root button's over here, square root of parentheses -3 squared minus 4 parentheses 2 parentheses 7 all over, so I highlight it, I hit the divide button, 2 times 2. And okay, it's undefined. Anyways, if I was trying to find my other answer, I would copy and paste it and just change the plus to a minus. Now, here, I see that it is giving me undefined. Desmos gives me undefined when I have a problem. And I will generally have a problem when I have no solutions. So let's look back at this equation really quick. So my equation that we're looking at is the 2m squared minus 3m plus 7. if I plug that into Desmos using x instead of m, I will see that my graph does not cross the x-axis. No x-intercepts means no solutions. And if we think back to our previous lesson, we only have no real solutions when our discriminant, or the stuff inside of our square root, is a negative number. So if I just copy and paste the stuff that was inside the square root, I will see that it is a negative number, negative 47. So the question is, what do we do now? And that is what we're going to be talking about today. So today we are going to be talking about complex numbers, adding, subtracting, and multiplying complex numbers, and finding complex number solutions of quadratic equations. So again, when I get a negative number inside the square root, we're going to talk about what exactly to do with that. Now, starting out, we need to talk about imaginary numbers. So here you have your definition. So this is our definition. This is my definition. Okay, so our definition is right here. An imaginary number is a number that is expressed as the square root of a negative number, and we call it I. I for imaginary. Some people think it's a stupid number. That's definitely why it got the name imaginary, because people back then, whenever they created imaginary numbers, also thought they were stupid. But these are actually really helpful for some math that has to do with electricity. So just trust, it is useful in the real world. And so we're going to talk about it today. Our key concept is this. Since I comes from the square root of a negative number, this is also pretty important to write down. I would definitely write this down, that I squared is going to be equal to negative 1. So if I see I squared that's the same as negative 1, you don't have to write all this down. But this little section here explains what we've got down here. So for example, if I had square root of negative 5, I don't like a negative in the square root. I want to get rid of it. So I do that by putting an I out front of the square root, and that would leave me with a positive 5 on the inside. So we're going to look at a couple of examples. So starting out, square root of negative 18. So there's a negative inside. I don't like it. So I'm going to rewrite this by putting an I out front, because that's the square root of a negative number, and then I am left with an 18 on the inside, just a positive 18. The negative got taken care of by putting the I outside. We are not going to simplify the square root of 18 yet. Okay, that's not our focus for this unit. If you take the square root of a number and find that it gives you a decimal, just leave it alone. Don't put the decimal down, just leave it as what it originally was. For the next one, same idea. I don't like that negative, so I'm going to rewrite this as I square root of 64. Now the square root of 64, when I plug that into my calculator, it does give me a whole number. Square root of 64 is 8. But when we write an imaginary number and I have a whole number next to it, so not a square root, not a decimal, whatever, I have a whole number next to it, I do like to write it with that whole number in front. So it should be 8i. Looking at the next one, very similar. I square root of 25 would be our next step to writing it. But then I see that square root of 25, that is 5, so I can rewrite this as 5i. Okay? Now, when we look at complex numbers are numbers that look like this. Okay, they have two parts to them. They're going to have a part that has I, and then they're going to have a part that doesn't have I. A real part, and then an imaginary part. So the part with I is the imaginary part. Think I for imaginary. So when we use complex numbers, we're going to look at adding and subtracting them. So we will do these two examples together. When we add complex numbers, we are just combining like terms. Okay, so when we combine like terms, I've got 4 minus 3i plus negative 4i, or negative 4, and then plus 3i. So I kind of treat I like x here. Anywhere I see terms with I, they are like terms. Anytime I see a number that doesn't have I, those are like terms with each other. So for example, 4 and negative 4 are like terms. So 4 plus negative 4 gives me 0. Those are like terms, I combine them. Negative 3i plus 3i gives me 0 as well. 0 plus 0 is just 0. And so that's it for this problem. For my next problem, I have subtraction. Now remember, with subtraction, something that changes is I need to distribute this negative. And what that negative is going to do is it is going to change the signs of the numbers that are inside of that parentheses. So when I change the signs, I'm going to change the signs in the second set of parentheses. Okay, I'm going to have 4 minus 3i plus 4 minus 3i. So now I can combine like terms. 4 plus 4 gives me 8. And then negative 3i minus 3i gives me negative 6i. And that's my answer. I have nothing else to simplify. That's my answer. So these you are going to do on your own and show me. These you're going to do on your own and show me. Looking at multiplying. Multiplying complex numbers is going to be very similar to how we multiply stuff with x. We are going to use the box. So I see that they're right next to each other. There's no plus sign or minus sign in between these parentheses, so I'm multiplying. I'm going to set this up. I'm going to set up what I'm going to multiply on the outside. So I've got 3i multiplied by negative 5 plus 2i. And this just helps me see how big my box is going to be. Starting out, I will do, in my first space here, I will do negative 5 times 3i. Negative 5 times 3 is negative 15, and then times I is just I. So I've got negative 15i in there. In the next space, I've got 2i times 3i for what goes in here. 2 times 3 gives me 6. I times I gives me I squared. So now that I have all the terms inside the box, I'm going to rewrite them outside of the box. So I've got negative 15i plus 6i squared. If we were just using x, we would be done. But reminder, I squared is negative 1. So what are we going to do? We are going to see where we have an I squared and replace it with negative 1. And then we are going to continue to simplify. So negative 15i does not change. Then 6 times negative 1 is negative 6. And now this is my answer. This would be the valid answer that I would accept on y'all's test. Right? This next one you're going to do on your own. So this one right here, do on your own. We are going to do this next one together. The negative 4 plus 5i times negative 4 minus 5i. So I will set up the box. I've got negative 4. Actually, let me set it up a little differently because some of us make mistakes. We're going to do negative 4 plus 5i times negative 4 minus 5i. And that'll help me make boxes. So first we'll do negative 4 times negative 4 for this first box. Negative 4 times negative 4 is positive 16. In this next space, I've got 5i times negative 4, which is negative 20i. Then for this space, we've got negative 4 times negative 5i, which is positive 20i. And then in this last space over here, we've got 5i times negative 5i, which is negative 25i squared. So when I write this all outside of the box, I am doing 16 minus 20i plus 20i minus, let me move this, minus 25i squared. Right? So I can combine like terms first. Let's do a different color. No. Okay, negative 20i plus 20i is 0. Okay, they're the same value, like absolute value, but different signs. So I add them together, they cancel out, is 0. And so really, I'm left with 16 minus 25i squared. But remember, I squared is negative 1. So where I see I squared, I should be putting negative 1. 16 minus 25 times negative 1. 16 plus 25. And this is 41. And so that's that problem. This one that's over here, you're going to do on your own. Moving on. Last one we're going to do together. My bad. But last multiplication one that we're going to do together. We have 3 plus 2i squared. This is still multiplying. We are still going to use the box. Remember that when something is squared, that is that thing times itself. So I basically just see it written down next to itself twice, like that. So I'm still going to use the box for this. So I've got 3 plus 2i on one side, and then 3 plus 2i on the other side. I make my box with the right amount of spaces, and then I start working. So I've got 3 times 3, that is 9. I've got 2i times 3, which is 6i. 2i times 3, which is 6i. And then I have 2i times 2i, which is 4i squared. So I've got 9 plus 6i plus 6i plus 4i squared. I can combine like terms. 6i and 6i both have just one I, so they're like terms. And when I do that, I've got 9 plus 12i plus 4i squared. And remember, I squared is -1. So this is really 9 plus 12i plus 4 times -1, which is 9 plus 12i minus 4. And 9 and -4 are like terms. So this final answer is 5 plus 12i. And that's it. And now that we have spent the whole time pretty much talking about how to use I and where I comes from, now we will be able to look at solving a quadratic equation with a complex solution. So in this problem, when we start out, we check, first of all, that it equals 0, and it does. So we can continue. I can identify A, which is 2, B, which is -3, and then C, which is 5. And then I can use my quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac over 2a. Then I do my whole parentheses bit. So everywhere I see letter, I am putting parentheses. And then I just replace what's inside the parentheses with the number that needs to go there. So -b is going to be -3. B squared is -3 squared. 4ac is 4. 2, 5 over 2a, which is 2 times 2. So I go to Desmos. So we will do this together. I go to Desmos. And I see that it's actually really similar to our beginning problem, but instead of a 7, there's a 5. So I don't really need to go through too much difference there. But it's still undefined. So I know the problem is inside of the square root. So I'm going to copy and paste and see what the number inside of that square root should be. Okay, I know that that should be a -31. So I know that this should equal something plus or minus the square root of -31. Now on the bottom, really quick, if I do negative of -3, that doesn't really show me anything, but it's really a -1. This should be a +3. And then on the bottom, if I do 2 times 2, that's 4. So on the bottom, we should have 4. And finally, the way that I'm going to write my answer, I have a negative inside the square root. I need to get rid of it. So I put the I out front of the square root, and I leave a +31 inside. And since square root of 31 is just a decimal, I can leave it as square root of 31. And so this is my answer. When I go back, when I go back, this is my answer. Okay? So anything that we didn't do together, so like this, please complete that work on your own and make sure that you show it to me so that I can check you off for your notes because that is part of your participation grade. And then I will give you the assignment that goes along with this lesson. If you have any questions, please let me know. But other than that, we are done.